One of the most important things that analysts do is that they forecast the future, and it's a very important business concept because we need to be able to plan for what we're going to do tomorrow and beyond tomorrow. And being able to forecast what's going to happen is one of the things that analysts really get paid to do. With that said, maybe the most important part of forecasting, though, is tracking your forecast and what actually happened so that you can reduce the amount of error between the forecast and the actual event that occurred. So again, we know that with forecasting that rarely are we 100% accurate. Instead, what we're looking for is we're trying to find models that reduce the error between the forecast and the actual, and we should always be striving to find just a bit better method. Whatever it may be, that's the real point. So in this video, we're going to discuss how do we calculate 3 important metrics that are associated with forecast error. I have some data here, 16 months worth of data where we have the amount that we forecasted and then the actual occurrence, what really happened. And with that, to get things started with determining forecast error, Excel has a way to put all of these months into a numeric format. However, I recommend when you get started, go ahead and put a time variable in and just label your new time periods, 1 to however many you have. All right. So that is the way that it will make your life easier if you just go ahead and do that. Error is always defined as the forecast minus what actually happened. Okay. In this case, we forecast 594. 592 is what actually happened. We over forecasted by 2. Another concept here is that we need to look at the absolute error. All right. And the reason for looking at the absolute error, if I take and extend all the way to the bottom on my errors, you see that sometimes I have a positive value, sometimes I have a negative value. If we took and just took the overall average of these, it says that on average, I'm only off by 43 points each month. However, we can see in here that that's really an underestimate of how much we're off, because being over by 131 or being under by 59, there's a big difference here. So oftentimes what we do to get rid of this negative value that's in here is we can either take the absolute value, all right, absolute value of the error, or we can take that error and we can square it. All right, in Excel, adding this little caret means to take it to that power. So this says take the error and square it. All right, and then once we get these in here, I'm going to go ahead and extend those all the way to the end. And we can see now that with this absolute error, that the average is much higher, right? When we're looking at the absolute error that we're off, we're really wobbling about 69 points each month. And I can go ahead and I'm going to extend this over here. And so what I've done is I've just taken the average of all of my squared values here. And the squared value really becomes a much larger number. But there are times whenever we're forecasting that squaring the error is important because it really punishes you on the months that you're significantly off. The last way that we look at error is in a percentage. And in percent error, what I'm looking for is how much absolute error did I have, and I need to divide that by my forecast. When this comes up, make sure that this is in a percentage. If it's not a percentage when you first pull it up, go to percent and then adjust your values to where you can see it. And now I'm going to go ahead and extend this all the way down. And I'm going to extend this value across. All right, let's make sure that this is in a percentage and extend it 1 digit. So it's telling us right now some very important things. One is the mean absolute deviation, also known as the mean absolute error. Error and deviation are often put in here. The MAD says that it is the average of all of our deviations is 69.12. That means on average, we are 69 points either above to below what the actual value was. The squared error, again, here's the squared error. The mean squared error is just the average of it. And then the mean absolute percent error takes each one of these months and breaks it down. Now, from what is the most useful, what I have found over many years of doing forecasting is this mean absolute percent error really is helpful to me. Because as you can guess, if the values for forecasting get exceptionally large, there's an absolute error doesn't help me. Or if they're very small, it is really hard to compare one set of values to another set of values whenever I'm using the absolute error or I'm using the squared error. But if I use the percent error, I can always go back and say, on average, I'm off about 10%. And again, as I mentioned to you before, as an analyst, being off by 10%, that may not be bad. However, if you can make it smaller, you should do everything you can to make it smaller. Next thing that I want to talk about is the bias. And on a bias, what I'm thinking about on bias is there something that's going on here? Do I oftentimes over forecast or do I oftentimes under forecast? If I highlight the time and the error here and I go to insert a scatter chart, we can see that here is 0. I have 1, 2, 3, 4, 5, 6 values or 6 times that I underestimated, but I also have 10 times that I overestimated. As a matter of fact, my overestimations go up to about 150, and rarely do I go much below 50 here. So from a bias standpoint, you can see that this forecasting technique that we're currently using oftentimes over forecasts. I'm going to go ahead and remove that. We also know that by just looking at the average of the overall error. On average, I'm over about 43.5. So even whenever I take out the months that I'm under, I'm over by about 43. So from a bias standpoint, there really is something here that's showing that, that I am over forecasting using this method. Now let's go ahead and look at a trend. And with trend, I include the absolute error because it says, am I getting better or am I getting worse at the absolute level? I'm going to insert a scatter plot again. And this time, whenever I insert it, you can see I have 2 different sets of values. I'm going to right click, select my data, and I'm going to get rid of the error because we've already looked at that. Now, whenever I bring back my absolute error over time, if I right click and I add a trend line, just like we did with linear regression, we're looking at a linear. We want to display the equation and display the R-squared on the chart. All right. The slope of the line is positive, so it's looking like on a month-to-month basis, my error is increasing by about 2 points. All right. So every month it seems like my absolute deviation is 2. However, once again, let's look at this model. What's our R-squared value? It's only 0.03. All right. So that means that the time only explains 3% of the variance in my forecast error. That's a very low number. Remember from what we talked about inside of regression. This model certainly says that something's there. However, it's really only explaining 3%. I think at this point I would probably have to pull back and say, there is potentially a trend, but this model really doesn't explain much of it. I would probably need to go back through and reevaluate later on to see if something's continuing there. All right, that's the basis behind forecast error. Again, we know that forecasts are almost always wrong. Being able to calculate a forecast error and then tracking it and trying to minimize that difference between the forecast and the actual is really what we get paid good money for to be an analyst. All right, thank you for being here.